All right, dude, we are live. What's up, guys? This is Dem Keys, and today we're going to continue learning about Rust. More specifically, we're going to focus on, or continue focusing on the Turbofish syntax. Yesterday, we took a short detour because I had some stuff going on, because of which I had to, keep. Well, let's just say yesterday's stream was a little different, and today, everything is much, much better. My system also seems to be doing a lot better health wise. I haven't had too many hitches, I haven't had too many freezes, lockups, or anything. And hopefully, it remains that way throughout the stream. At least for the next 2 hours, if it remains that way, we are golden. Give me a second. As soon as I start the stream and I'm praising it, all of a sudden there's internet issues. Give it a second, let the thing stabilize, and let me also do something that I think might help uh, put a lesser load on the connection. Okay, I think we are doing better now. Where was I? Yeah, so, other than potential internet issues, everything else seems to be going a lot smoother. And hopefully it remains that way. Today, also, I just so happened to have started the stream earlier, and this means that I have a good like two, maybe even 2.5 hours. Actually, if I wanted, I could probably even go for three, but I don't think my vocal cords are gonna like that very much. So I mean, I'll probably be able to go for at least 2.5 hours. So yeah, dude, let's see how much of the Turbofish syntax we are able to explore today. Okay, now, um, previously we were at this point where we were learning about collect. And I remember I had a conversation with Gemini about this. We were diving into, yeah, okay, I'm sorry, I'm trying to remember, I'm trying to like recollect all of that stuff because yesterday and today as well, I think. Yeah, yesterday and today, some of my, now that I think about it, not just some, all of the stuff that I'd ordered online, it arrived yesterday. A bunch of ICs, a bunch of modules, a bunch of sensor modules, and also other modules. There was stuff like what do you call it? Logic level converter, 3.3 volts to 5 volts. Oh yeah, dude, I need to test that out. I need to find something to test that with. And I think I do have just the thing for that because there are certain modules that I have that are 5 volts. They're not 3.3 volts. And I believe the older Arduino Unos, they operated mostly in like 5 volt range. And so, if you would buy, I don't remember how accurate that was, but there are definitely older modules that if you go to buy them, maybe you still get them like in that range, but like a lot of the microcontrollers these days they operate within the 3.3 volt range. But back in the day, yeah, there was like a 5 volt thing going on. Again, I don't know how common the 5 volt thing is now. If you're buying newer hardware, you could still be buying hardware now that is older hardware, and so maybe you'll still get the 5 volt thing. But anyways, yeah, I believe the older Arduino Unos, they operated within the 5 volt range, and so if you were buying various types of modules that were specifically meant for the Arduino Uno, then there's a decent chance that they would be operating in the 5-volt range, not 3.3-volt range. Let me just, actually, I'm curious about this now. I want to look this up. Is Arduino Uno 5 volts or 3.3? The Arduino Uno Rev 3 primarily operates at 5V. It's 80 mega 328p microcontroller, digital I/O pins, and analog inputs are designed for 5V logic. While it has a 3.3V pin for low power components, the board's core logic and power regulation are 5-volt based. Okay. So I guess that explains why back in the day when I was getting, because like I'd been gifted an Arduino Uno by my family on one of my birthdays. That's actually what introduced me to microcontrollers. It's thanks to them that I actually got introduced to microcontrollers. They also bought me a project kit. It's like I don't remember exactly how many, maybe 5 in 1, 10 in 1 project kit. So it's basically a kit with a bunch of components and modules and peripherals and stuff that you can use to assemble various types of or put together various types of projects. So they sell like these entire kits, and of course you're not limited to just the specific projects that the kit is meant for. These are components that you're meant to put together, right? You can put them together however you want, and you can come up with your own project idea and make your own thing. But this kit gives you a bunch of things to play around with. Why was I talking about this? Yeah. So okay, there were a bunch of different modules in there, including stuff like an LED matrix driver. There was an LCD screen. I don't know if it was LCD or some other kind of display. Maybe, okay, not LCD. It was a display, but it was something not not even like a. It's not even a 7 segment display. It's definitely a screen. You can control like pixels on it. I don't remember exactly what type of screen it was, but it's not like an LCD screen. Um, what are those things called? I keep thinking black and white, but it's not that's not what I'm thinking about. Black and white, there is no white in that. It's more like, but there's also no color. So like, okay, the monochrome is a word that's coming in my mind. So let me see. Monochrome display. Is that give me a second. That's it, monochrome display. Though this is being marketed as an LCD display. Let me open up a conversation with Gemini. We're gonna get to the Turbofish thing. I don't want to get too distracted with, the electronics as excited as I am. By the way, yesterday after the stream, I set up. I tried testing out one of the ICs that I got. One of those ICs is an AND gate. It's a quad 2 input AND gate. So that means there are 4 different AND gates in it that are operating independently. So you just power up the IC. You give positive to VCC and negative to ground, and then you can use any of the other pins for and logic. And I learned something about these specific types of ICs. Apparently, because of the way that they operate and are built. In fact, it has something to do with CMOS, with the fact that it's a CMOS logic kind of thing. I'm still doing research on that, so I can't really give full information on why it operates that way, but I can tell you what it does. Basically, the idea, and this apparently comes down to digital electronics. Apparently, a lot of digital electronics tend to do this. I've actually noticed this with ESP32 as well. So it's the idea of a floating pin. When a pin doesn't have anything connected to it, it's basically a floating pin, and the state in that case is undefined. So it could be on, it could be off, it could also just be constantly flickering. So like it could be switching between on and off constantly, because when it's in a floating state, it's apparently picking up electrical signals from everywhere, including static electricity, anything that might be in the air. Maybe if you touch it, then it's picking up something from you. And so the state of it. So like if you try to power something using it, let's say you try to power an LED, of course, with a resistor, you're going to start seeing flickering, like dim, very dim flickering, and it's not going to make sense exactly what's going on. And that's because it's in a floating state. Yesterday, what happened is, so okay, with these AND gates, they're two input, so you give it input A and input B, and based on the logic, it's then gonna, well, based on the rules, based on the truth table, based on the rules of and, what's the word I'm looking for? Based on the rules of and logic and conversion and calculation. No. Based on the and truth table, you'll get an output. So basically, you give it two inputs and you get an output. And depending on whether the inputs are high or low, your your output is also going to be high or low. I don't remember if 0 and 0 counts as counts as 1 or not, or is that like an exclusive? Actually, no, even an exclusive. Well, no, yeah, under exclusive it should count. Yeah, I don't remember because like okay, with an and truth table, the whole idea is input A and input B should be should be true. It should be true in order for the output to turn out to be true. So if input A is 0 and input 0 is false, and 1 is true. So if input A is false and input B is true, then the output is going to be false. If input A is true and input B is false, even then the output is going to be false. If input A and B are true, then the output is going to be true. I don't remember about 0. I think 0, I think if both of them are 0, then the output is also false. Because like even though it's like, 0 and 0, it's still false. I believe it's false. Let me look at the and truth table. And truth table. Okay. It is 0, 0 is 0, 0, 1 is 0, 1, 0 is 0, and 1, 1 is 1. Right. Okay, so here's what I did, right? There's three pins, let's say for one of the AND gates in that IC. There's three pins. You're supposed to give it A and B as inputs, and then you get an output Y. So in my case, I was planning on powering an LED using the output of the Y pin. What I what I was assuming was that if I just don't give any input, because I completely didn't take this into account. Actually, it's not even that I didn't take it into account. I didn't know that that's how this chip operates. What? What did I just operates? I didn't know that this is how this chip operates. And what was I saying? I stumbled upon my words, and hold on. Did I just say I stumbled? I fumbled. What is going on with my dude? Just okay. Wait, wait. Hold on. Words. I'm not able to word. I I I'm not getting words. I cannot word. Hold on. Wait. What was I saying? What was I saying? I was talking about the IC. I was assuming, and I was about to say yes. I was about to say that I did not know that this is going to be the behavior because I didn't know that this is how the IC works. I didn't know that there's a whole floating pin thing, floating state kind of thing. And so I decided to not give A and B any input and only take output from Y. And what I noticed is that the LED just kept flickering, and randomly it would light up. Sometimes it just wouldn't light up, and I couldn't make sense out of what was going on. I was worried that the IC was um, maybe defective or faulty or something. And sorry, zoned out. Yeah, I was worried that the IC was faulty, but then I asked Gemini about this, and because I was actively having a conversation with Gemini about this specific IC, and I had also mentioned the IC model number. So that's when Gemini said, "Welcome to the world of CMOS logic." And then Gemini explained the whole floating pin thing, and it also mentioned that, yeah, this is how it works with digital electronics. A lot of times you don't really want to leave pins in a floating state. You want to either give them, like, you want to have something, you want to have them connected to something, and then specifically give them either, voltage or no voltage. No voltage, if you're looking at an analog circuit, generally, quote unquote, no voltage would mean that it's attached to ground, and voltage would mean it's attached to VCC. So, yeah. So I then did that, and yeah, the IC works. So I was happy about that. Anyways, okay, enough enough talking about this. I need to. I don't even remember why I was talking about the monochrome displays. But yeah, now that I'm looking it up, yeah, these are the displays that I'm talking about. In fact, I should see if these displays are still available, and are they cheaper than getting like LCD and LED displays? Because if they happen to be cheaper, then I would happily order more of these. You know what else I want? Because I'm seeing it right now. I want e-ink displays, mostly because of how thin they are and how simple the display is. I also don't think they take too much. Um, I don't think it takes too much to power them. Wait. Monochrome display. ESP32. Monochrome display module, ESP32. Let me just look that up. I2C 1602 LCD display. It seems cheap. It seems pretty cheap. Yeah, it's not gonna have well, okay, I could also get limited color versions, because I'm assuming that, the more color the LCD or the LED is able to, the more color the display is able to put out, the more expensive the display is going to be. I could be wrong about that, but I think it's the physical makeup of the display that allows it to put out more ranges of colors, and that is why building the thing becomes more expensive. Um, Hold on. What am I looking for exactly? So there is OLED display. I'm just gonna actually, no, wait. If I open that up right now on my stream, wait, SSD 1306. Didn't I see 1306 earlier as well somewhere? Okay, wait. SSD 1306 OLED display. Um, okay. I'm at this point not gonna buy, but I just want to see how much more expensive it would be. And like, I mean, if I'm able to get it for like $1 or $2, that's amazing. That would do. That would be amazing because I haven't had the chance to play around with LED drivers a whole lot. So like I can at least start writing logic for LED. Have I been saying LED? I mean display drivers, display modules. I haven't had the chance to play around with them a whole lot. I do have like I think three or four um, TFT displays, and they're full color, at least from what I know. So I mean, I can definitely play around with those if I want. Um, Give me a second. I'm just looking to see how much these displays cost, and it they don't seem to cost a whole lot. You get like these very small displays. They're like 0.96 inch. 0.96 inch seems to be like a very common sort of measurement, and you're able to get them for a decent price as well. Looking the price that I'm looking at here, if I convert the we can say two to $3, I think. Somewhere between $2 and $3. Or in fact, yeah, yeah. Somewhere between $2 to $3 for each of these displays. And maybe if I buy a pack of like 10, then I can get, a discount or get it in like wholesale price or something. But yeah, dude, I should have looked into this. The thing is, back when I was looking into these displays, I wasn't looking for these displays specifically. I was aiming for the TFT displays because the whole color thing, it was very appealing to me. And I'm still planning on using those displays, but um actually wait, those displays, now that I think about it, I think a couple of them do already have the headers soldered on, so I could directly start using them. I guess I was waiting to learn how to use the various communication protocols that are available, I2C, I2S, SPI, and there's two or three more. I was waiting to like familiarize myself with them just so I know what I'm doing. But yeah, dude, these are nice simple displays. If I wanted to do robotics related stuff, I would definitely go with these displays. Like, dude, these displays are actually cheap. Hell yeah, dude. There's one thing here which I can get for okay. There's pack of uh, it's like 1 to 10. So if I go for oh okay, I was expecting yeah okay. You know what? That's fine. That's fair. What about the cheaper one here? This is a D. You know what? Even okay, they're still not like that expensive. I'll definitely mention that. They're not like super expensive. Dude, how long have we been streaming? I was saying that I won't get distracted with electronic stuff, and here I am, distracted with electronic stuff. To be hold on. Yeah, to be fair, I am planning to stream longer today, so we do have some time. Give me a second. Okay. Also, yesterday I got done uploading the last of the 2025 VODs, and now at this point, the VODs channel has all of the 2025 VODs in it. all the way up to the 31st of December. So today I'm going to start uploading the 2026 VODs. So from the beginning of this month, and every day I'll upload like maybe three or four, and in a couple of days, or maybe in like a week or two, we should be done with those as well, and we should be all caught up with the current VODs. And I want to start my clip generation thing from the very first VOD of this year. I do need to set up the auto clipper thing on in a Kaggle notebook, just so I can run the models there and not have to worry about my own hardware heating up a whole lot, because Kaggle does give you free resources. They give you a certain amount of, not just they give you like a lot of CPU time and a lot of RAM, but they also give you a certain amount of GPU time per week. There's a certain number of hours of GPU time that you get per week. And I feel like for this purpose, for like what I'm intending to use it for, I can get a lot. I can get a lot of work done with that. And as it is right now, I'm not really using the GPU resources that they're providing. At least for data science stuff, I'm not using the GPU resources just yet. Once we move further with data science, then I'm definitely, actually, in fact, not even just data science. Once we move further with deep learning, I'm probably going to be using their GPU resources a lot more. But for the time being, because I'm not using them for anything, so I might as well use them for my auto clipper and get some get some use out of them. Okay, so displays. Yes. These also, I'm pretty sure if I look online, if I look for ESP32 related drivers, or just um, drivers that how do I say this? Drivers that implement drivers that run on embedded HAL, or uh, even what was it called? Embedded graphics. Yeah, because you have the embedded HAL and the ESP32 HAL or ESP HAL. It runs on top of embedded HAL, and then you have the embedded display. I forgot. I forgot if that runs. I think that runs like directly on embedded HAL, not on ESP HAL. I'm gonna have to look at that stack again. But yeah, my point is, um, probably these displays have been, or drivers have been written to run on top of embedded graphics, and these would be more of like a grayscale kind of thing. We wouldn't be dealing with color here. We would be dealing mainly with lighting up the pixels. I need to see. Hold on. What is the thing? SSD 1306 OLED display. Um, let's look at the data sheet. What voltage is this meant to operate at? Okay, so the display is called a dot matrix, and it's a 128 by 64 display. Give me a second. Okay. I'm pretty sure someone has written a driver for this. Definitely someone has written a driver for this. I just need to go look for it. Also, I'm trying to look for the max ratings of this. Okay, maximum ratings. There you go. Supply voltage. Wait. There's VCC and there's what looks like VDD. Hold on. Yeah, there's VCC and VDD. VCC can be anything between 0 to 16. That's interesting. And VDD, I need to look into what that is. It says it can be anything from negative zero point 0.3 to positive 4 volts. Okay, is there like a current rating? Though I wouldn't need to worry about current rating in this case because I'm mainly going to be connecting GPIO pins to it, and even like the protocol related stuff is not going to be going into very high currents. So it's mostly digital communication, is what I'm saying. There's not going to be a whole lot of analog communication going on. Um, Condition voltage reference to okay. So all right, VDD is 1.65 to 3.3 volts. Right. Okay. Operating voltage, um, minimum 7 volts and maximum 15 volts. Okay. VDD, logic supply voltage, minimum 1.65 volts and maximum 3.3. So there's a different thing that I have to use to power this. So like, okay, you have the logic. This kind of seems like a similar situation to, well, no, I don't know if that's fair to say. Kind of. It's kind of a similar situation to like those motor driver modules where you give it like an external power, which is meant to power the the motors themselves. You don't plug your ESP32's power stuff into that, or you don't plug your ESP32's data pins into that. But then you have a separate logic section, which is mainly 3.3 volts. That is what you're supposed to connect your ESP32 into. This kind of seems like that kind of a situation where I need to power it externally and then use the ESP32 um, to do the logic stuff. Though, yeah, I need to hold on. Um, I'm thinking of buying a bunch of SSD 1306 OLED displays for various ESP32 projects. I'm concerned about the voltage and current requirements. Current is not going to be so much, but then I'm just, mentioning it anyways. Okay, it's a smart move to double check the specs before bulk buying. The SSD 1306 is practically the Hello World display for the ESP32. And they are generally very forgiving, but there are a few nuances with power you'll want to keep in mind. Voltage compatibility. Most SSD 1306 modules are designed to be dual voltage compatible. So you have logic level voltage, which is the ESP32 operates at 3.3 volts. Fortunately, the display is a 3.3 volt native device. And then you have supply voltage. Most modules include a small onboard voltage regulator, allowing them to accept 3.3 volts to 5 volts. Then the sweet spot, connect the display's VCC to the 3.3 V pin of your ESP32. This keeps the logic levels constant and prevents the ESP32's GPIO pins from being exposed to 5 volts, which they aren't officially rated for. Okay, current consumption. The beauty of OLED technology is that it is emissive. There is no chunky backlight. There's no chunky backlight. Okay. Um, Only the pixels that are on consume power. So idle slash static, if the screen is off or displaying very little text, it draws around 1 milliamp to 5 milliamps. Typical usage with a standard UI, text and some icons, expect a draw of uh, 10 to 20 milliamps, and full white. If you light up every single pixel at maximum brightness, which is not recommended for long periods, it can spike to 40 milliamps to 60 milliamps. Note, the ESP32's onboard regulator can typically handle an extra 50 milliamps without breaking a sweat, so powering one or two displays directly from the ESP32 pins is perfectly safe. Okay, so now I need to ask this question. I can look into the voltage and current thing later on, but I need to ask this question here. Okay, I looked at the data sheet for the display, and there's a table mentioning what exactly did it mention? DC characteristics. DC characteristics. Okay, I think I spelled that wrong. Characteristics. Oh, I spelled character wrong. There you go. Okay. DC characteristics. And in that, one of the rows says VCC operating voltage min 7V, max 15V. This has me confused a bit because it seems like I need to give it that amount of voltage. Okay, I totally see why that would make you do a double take. Seeing 7V to 15V on a datasheet for a tiny screen meant for a 3.3V microcontroller feels like a recipe for a magic smoke show. The confusion stems from the distinction between the SSD 1306 chip, which is the silicon driver, and the OLED module, which is the PCB you actually buy. The secret, the charge pump. The OLED pixels actually require a relatively high voltage to glow, usually around 7 to 12 volts. This is the VCC referenced in the DC characteristics table of so and so. However, you don't need to provide that. The internal okay. The internal boost. The SSD 1306 has a built-in charge pump. This is a clever internal circuit that takes your low input voltage, which is 3.3 volts, and pumps it up to 7V plus, pumps it up to the 7V plus required to light the pixels. The module circuitry, the PCB modules you buy for ESP32 projects are designed to handle this for you. They route the 3.3 volts from your VCC pin into the chip's power rails and use a few external capacitors to charge that internal boost. Understanding the data sheet terminology. If you look closer at the datasheet, you'll likely see two different voltage pins mentioned, VDD and VCC. Right. Okay. VDD is the logic voltage. This powers the brain of the chip, and VCC is the panel driving voltage, which is the 7V to 15V you saw. This powers the actual light. In almost every hobbyist module, VDD and VCC at the pin label are tied together at the pin labeled VCC on your header. Okay, when you initialize the display with your code, like the Adafruit so and so whatever libraries, You send a command to enable the internal charge pump. This tells the chip, hey, I'm only giving you 3.3 volts. Please generate the higher voltage yourself. Okay, all right. That helps, definitely. Okay, now I'm going to step away from this before I end up getting more distracted. I need to go back to that Turbofish conversation that I had going on. So let me open up that convo as well with Gemini. I had it somewhere here. Give me a second. I have a couple of these conversations that I had opened up. Okay, okay, okay. I'm also kind of looking into doing another project, which is a sort of very simple circuit designer, schematic diagram designer using Rust and Godot. I want to make something incredibly lightweight, specifically for only building schematics, not simulating anything, just drawing the schematics. And I want to see if I can make it like as lightweight as possible. And then I'll put it up on GitHub and let people describe or define multiple custom components that they want so they can then, add those components in. But the thing is, I need to come up with my own logic for drawing and connecting the components together, because there's going to be you're going to have the components. The components can have multiple pins, right? So then by that logic, it could be an LED, it could be a resistor, a capacitor, a diode, a transistor, which has 3 pins, an IC, which can have anywhere between 4 to I don't know, 20 pins. I'm definitely not building this for something that requires 20 pins, but we're going to give that option. So there can be multiple such nodes, and each of these nodes is going to have multiple pins. So the logic should allow wiring between the pins of the nodes. And I need to come up with the logic for that entire wiring thing, and also the very specific look that schematics usually have, where you have like 90-degree wires, so it's not like diagonal wires. I want to stick to a very specific look, so all of those things I have to take care of them. But I feel like that would be a decent project to work on in Godot, and it would also give me a good experience of working in Godot, or it would help me build my experience of working in Godot. Okay, I was looking at, okay, there's pet graph, there's circuit diagram for pet graph, there's a whole bunch of these conversations that I need to unload so I can load up some of the other Gemini conversation. There was a specific Turbofish conversation that I was having. Um, we're gonna get back to this Turbofish thing. That's why I wanna load up that convo. Okay, parser, Turbofish. Okay, we have this. All right. Let's go back to Turbofish. The methods you used are so and so. Okay, all right. There was another place where I was having the conversation about. Okay, this is about how Turbofish is meant to be used. Um, Wait, I'm gonna get there. I'm gonna get there like soon. There it is. Okay. So, previously we were looking at this code over here, and I was confused about, do I still have that code generated? No. Um, so we are gonna implement the default members and then scroll down to collect. Here's collect. So what I was confused about here was how exactly from iterator is able to, well, from iterator, from iter, how they're able to get the type in that case, and why we don't need to specify, a certain type over here, and how it is that I'm able to actually use this. So I had asked a question to Gemini in Gemini Web, and yeah, Gemini gave me the response, which I'm gonna be reading out because I'm trying to understand how this whole thing works. And this introduced me to a new concept called backwards type inference. So we're going to be looking into that. But before that, I need to take a short break. I'm going to step away for a couple of minutes. And yeah, I'll be back in a couple of minutes. I'm just going to switch to BRB and mute the mic. And yeah, I'll be back. Okay, I'm back. Give me a second. Let me just hydrate and then we can continue. By the way, since we are going to be doing this project of like creating an internal mind map, what was I going to call that? Yeah, just mind map of my dialogue, like as I'm speaking, creating a mind map of my speech. That thing that I'm planning on working on, it's going to involve a lot of NLP, and we're going to be learning a lot about NLP, which I'm, by the way, really excited about because I wanted to learn about NLP in the past, and I just never really got around to doing it. I guess I don't know if I don't remember what the reason was. I think I did look into it a tiny bit, but I didn't go too deep into it. What was I gonna say? Oh yeah. Well, okay, this, to be fair, this doesn't have much to do with um this doesn't have much to do with NLP. though it could have something to do with NLP. This is more to do with automatic speech recognition. So I need to find a way to use ASR to detect my ums and ers, or ums, ers, and ers, because I have all three of them. I have all three of them going on. So what I want to do is I want to try building a sort of and dude, if I'm able to run this on an embedded device, that would just be holy shit. That would be amazing. Even if I'm not able to, I can like build something that runs off of the that runs on one of the computers, and then I just send the output to a microcontroller that lights something up. But yeah, that's the idea, that I'll have something that lights up anytime it detects something that I said, that I'm trying to add a signal for, something that I'm trying to avoid saying a whole lot, which is stuff like that. If it did, there's the again. If it detects it, then hold on. I was supposed to be hydrating. Let me. There's the again. Now hold on. Just let me hydrate, and then I'll continue. So there's two things that we can look into here, right? There's the again. Just there's the again. Hold on, just a minute. Wait. There's the again. I need to. Okay, you know what? Whatever. Hold on, just a minute. Let me do the thing that I'm doing. And there's actually something else that I need to do as well. Uh, just a minute. I need to handle something. Okay. All right. Yeah. Now, back to what I was saying. So, there's a couple of things that we can do here, right? One of them is where was I going with this? There are two things that we'll be focusing on here. One is ASR and one is NLP. If it's specifically for detecting speech and not transcribing the speech, then it's mainly ASR. And then I need to find a way to detect ums and ers each time. But I don't want to use transformer based models. I don't want to touch Hugging Face transformers for this specific thing, because this needs to be incredibly fast. This needs to catch it like the moment I say it. How am I going to do this? Okay. We're going to take a quick detour here. Um, okay, there's the arm again. Hey, so I want to use Vosk for ASR and NLP. I've been told that it is incredibly fast compared to transformer based models using HF transformers. Uh, but at the same time, it may not always provide you with the quality that you could get with transformer based ASR models. Correct me. Actually, wait. Okay, let's just say enlighten me on this, please. What I'm hoping is that it's going to tell me that while, yeah, that is kind of true, Vosk, Vosk has improved a lot over time and it's gotten much better. Enlighten me, please. Explain to me how Vosk ASR models are different than the ones I would then let's just say than the transformer based ones, and how they tend to be faster. Okay, also I want to work on a small project. I want to work on a small program that uses ASR to detect fillers in my speech, such as um, er, and so on. This needs to be incredibly fast, like real time kind of fast. What would you suggest for this? So we're going to ask this question and see what, oh, it's using the thinking thing. Actually, in this case, yeah, it's probably a good idea if it's using its thinking hat. Because I get like a fixed number of thinking prompts per day for free. So I like to kind of budget the usage of it. Okay, you've hit the classic trade-off in the speech world, speed versus semantic depth. Vosk is essentially the Formula One car of ASR, stripped down, incredibly fast, and optimized for a single track. While transformer-based models like Whisper or Wave to Vec 2 are more like luxury SUVs packed with features and intelligence, but much heavier to move. That's a good analogy, actually. Okay, why Vosk is incredibly fast? Vosk is built on on the Caldi toolkit. Its speed comes down to its architecture, which is fundamentally different from the attention mechanism used in transformers. WFST-based decoding. Vosk uses weighted finite state transducers. Think of this as a precompiled, highly optimized graph of possible sounds and words. As you speak, the model simply walks through the graph in real time. It doesn't have to rethink the entire sentence. It just finds the most likely path. Linear complexity. The computational cost of Vosk is roughly OT, where T is the duration of the audio. In contrast, standard transformers have a complexity of OT squared because every part of the audio attends to every other part to understand the context. Okay, CPU optimization. Because it doesn't rely on massive matrix multiplications across a global context, VOSC can run on a single CPU core, even on a Raspberry Pi, with negligible latency. That is interesting. I didn't know it's using like a graph-based approach and just like traversing a graph. Or maybe that's a simplified version of this, but it does seem like it's going through a pretty sophisticated graph, but like traversing through it very quickly. That's interesting. Okay, the quality gap, phonetics versus context. If VOSC is so fast, why use transformers? The difference lies in how they understand you. Right, logic. VOSC, acoustic phonetic. It listens for specific sounds and matches them to a dictionary. Transformer, semantic contextual. It predicts words based on the meaning of the whole sentence. Right, handling noise, struggling. It relies heavily on a clean signal. That's something to keep in mind. Whereas with transformer based models, it's excellent. It can guess the word based on the context, even if obscured. Global context, very limited. It usually looks for a few words back, slash, it looks only a few words back, slash ahead. And transformer global context is high. It understands how the end of a sentence changes the beginning. All right. Detecting filler words in real time. For your specific goal, detecting and in real time, VOSC is actually the superior choice, but with a catch. Most high quality transformer models are specifically trained to ignore filler words, disfluencies. That's what it's called. Okay. Because users typically want a clean transcript. That's something important to keep in mind that the models that I'm looking at usually, they are meant for transcription. I didn't take that into account that because they are meant for transcription, so they're probably going to be operating in a way that kind of cleans up the text a little bit. For some reason, I was assuming like a one-to-one transcription, including, ums and ers. But then, yeah, it's a good thing that they're ignoring it. Um, Vosk, however, is much more literal. If you tell it to look for those sounds, it will find them without trying to fix your speech. My recommendation, the grammar approach. To make it real-time fast, don't just use a generic Vosk model, use the Vosk grammar API. This restricts the model to only recognize a specific set of... Dude, I feel like I need to explore Vosk a lot more. Because if I'm trying to do ASR and NLP, it seems like Vosk is the more I was about to say the more superior choice, but like it's the more beneficial choice for me here in terms of learning the concept of ASR and NLP. I don't know how much of NLP is. Oh, no, I'm okay. Vosk is definitely used for ASR. I don't remember how much NLP ability it has, or how much NLP related stuff you can do through Vosk, because Vosk is again for ASR. I forgot what I was saying, but I was going to say that doing ASR through Vosk, I feel like I'm going to get to learn a lot more about ASR than if I was mainly relying on transformer based models, which I should get to that as well at some point when I have the hardware for it, when I have the hardware resources for it. Right now, I don't have the hardware resources for it. Give me a second. I just need to open something up so I have some background sound. Let's not have that background sound because it's going to get, yeah. Once there is audio in here, or speech rather in here, then I can do something. But yeah, okay. I feel like I'm going to get to learn a lot more about ASR if I start doing stuff with Vosk, because there's a lot of like concepts that I need to explore, and I'm only going to be able to explore them if I'm doing them, you know, through this API. I'm sure there's probably transformer based stuff for ASR as well, various toolkits that use transformer based stuff. But I mean, based on the hardware that I have, I don't think that's going to work out. I also there's also the fact that I want to run this on embedded hardware eventually. Initially, it's going to start with computers, but then eventually I want to move this over to embedded hardware because it's going to help me. Well, in general, I just want to be able to do it on embedded hardware. That's one of the things. I just want to do it for fun. But also, um, if I do manage to do it, it's going to help me in robotics as well and any other, like, speech related projects that I might have. It's going to help me big time in all of those. I can maybe set up like processors that do ASR or NLP processing. Somebody did mention something because Vosk specifically is not available for ESP32 or embedded hardware in general. I remember them, I think it was back in 2021, somebody had asked this question on their GitHub, and they had said that yeah, Vosk is not, it's not meant for that. There's, I mean, that could have something to do with the fact that Vosk is built on top of Caldi, and Caldi itself is probably not meant for embedded hardware. So I need to look for some. Though, okay, keeping that in mind, that's not to say that there won't be anything Rust based. Maybe people have worked on um, ASR and NLP frameworks, to be more precise, no STD compatible ASR and NLP frameworks. Okay, so let's look at um, ESP32 Rust. Okay, first let's look at Rust, because if I look at ESP32 speech recognition, it brings up the ESP32, um, well, speech recognition thing, right? That's a problem because the ESP32, specifically ESP32 speech recognition thing, is C++ based. It's not Rust based. Something I could do is I could try asking in maybe in the Rust Discord if someone has suggestions for no STD compatible ASR and NLP frameworks. That just occurred to me because I was thinking of asking in one of the GitHub repos. Where was I going to ask this? Maybe in the ESP Rust repo. Yeah, maybe in the ESP Rust repo. Speaking of which, I should probably look for a Discord of ESP Rust. Let me see. ESP Rust Discord. I don't know if there's like an official ESP Rust Discord. Um, I don't just want. I think I've joined the. Oh, I could join the Espressif Discord. Right, ESP32 Discord. 6 years ago, someone asked this question. Okay, ESP Home. Join this server if you want to help. If you want to help or want help with ESP Home based ESP Home based projects. I'm looking for ESP32 specifically. What about the Espressif Discord? Espressif MCUs, Espressif chips Discords. You know what? Okay, I'll look for the Discord later on. Dude, we're supposed to be doing holy shit. We are 1 hour and 10 minutes into the stream. We're supposed to be doing Turbofish stuff, but I keep getting distracted. We're gonna come back to it. Okay. ESP32, um ESP32, no wait. Rust speech recognition, no STD. There's something called Fry. I don't think it's maintained anymore, though. I do remember looking into this. This was archived back in 2024, so it is not being used anymore. It's not being developed anymore. No STD mode is usually set for cases where STD is not available, such as operating system kernels. An ordinary app may choose to opt out, and so on. So, okay, there's something called Magical RS. Level 1 and Level 2 both support no STD. Level 3 custom runtime file. What is Magical? One of the best. This is for file recognition. This is not what I'm looking for. Uh, no STD. So and so. Yeah, I feel like no. You know what? Hold on. Let me see if I can ask Gemini. Hey, so I do ESP32 projects in Rust. Recently, I've been getting into ASR and NLP. I'm looking for frameworks um, that are no STD compatible so that I can use them to do ASR slash NLP on ESP32. Oh, don't do the thinking thing. Just give me a fast answer. Okay, doing ASR and NLP on a no STD ESP32 target is a boss level challenge. Okay, that's not encouraging. But the Rust ecosystem has matured enough to make this possible, provided you manage your expectations regarding model size and latency. That's fair. Okay. Since the ESP32 has limited RAM, I did not take that into account. We have the models, we have the model, but then we also need to have the weights, and the weights are usually massive. Okay, since the ESP32 has limited RAM, typically 512 KB SRAM or PSRAM, I think the ESP32s that I have are probably even lower than that. You won't be running full Whisper or GPT models. Instead, you'll be looking at keyword spotting and intent recognition. Okay, cool. That's why I didn't mention transformer-based models. I specifically said ASR, so it can be any ASR related thing. Okay, top frameworks. Top framework recommendations. Burn. Burn is currently you are okay. This is a deep learning framework. Burn is a deep learning framework. Okay, wait. Let's go along with this. Let's see what it says. Targeting ESP32, you would use the ND array backend, find compatibility, perfect for small NLP. Okay, fine. Note, you will likely need to enable the alloc crate and use the ESP32's PS RAM. Okay, then candle alternative. Dude, okay, specialized ASR NLP libraries. If you don't want to build a full neural network from scratch, okay, now we are getting somewhere. Look at these specific utilities. ASR, NLP, Rust tokenizers. Hold on, what all is tokenizers able to do? Some tokenizers like WordPiece can be used in NLP environments if you provide the vocabulary as a static byte array. Okay, then there's math slash DSP, micro FFT, enabling, no, essential for ASR front end. You'll need to convert raw audio to spectrograms before feeding them to a model. Implementation strategy. Um, okay, hold on. Because I feel like if I tell you what I'm trying to get the embedded hardware equivalent equivalent of, then you might be able to help. Um, I am planning on doing Rust projects using Vosk for ASR and other pure Rust crates for NLP. Something very different about these crates is that the ASR and NLP methods being used won't be transformer based, and so will hopefully be much lighter. I was hoping you would recommend something that would help me accomplish that. Well, that, but for embedded hardware. I want to learn low level ASR, or let's say I want to learn the building blocks of ASR and NLP. I don't necessarily want to use transformer based transformer based models because they tend to be much heavier. And I want minimum latency. Okay, that makes total sense. You're looking for the old school GMM/HMM approach to ASR and rule-based or statistical NLP. The kind of tech that powered speech recognition for decades before transformers took over. In the embedded world, these are actually superior for your use case because they are deterministic, have predictable memory footprints, and offer near zero latency. Here's a no transformer stack for no STD so and so. Okay, Vosk is based on Caldi, which uses finite state transducers and hidden Markov models. To replicate this on ESP32 without STD, you need the building blocks, the signal front end. Okay. All right. So they want me to get the raw audio and then turn it into get the raw audio and then turn it into a spectrogram or perform some other kind of operation on it. And then we have the decoder. Instead of a giant neural net, you use a Viterbi algorithm to find the most likely path through a state machine. Framework, RHMM, Rust Hidden Markov Models. Embedded note, while RHMM uses ND-array, you can configure it for no STD with ALEC. It implements the Viterbi and Baum-Welch algorithm. Baum-Welch. Right, anyways, okay, Baum-Welch algorithms, which are the exact building blocks you asked for. The logic, you train an HMM for each phoneme or word if doing isolated word recognition on the ESP32. You compare the incoming MFCC features against these HMMs to see which one matches best. Dude, looking into these building blocks is really interesting because now I'm getting like really interested in actually exploring ASR and NLP on a lower level, possibly without involving neural networks. But like as I get deeper into deep learning, nice. As I get deeper into deep learning, I could try to solve these same ASR and NLP problems using my deep learning knowledge. I think what's going to end up happening is as I learn more and more about deep learning, I don't think I'm going to be exploring like, all that many neural network architectures. The four that I'm specifically focusing on right now are feed-forward neural networks, um, convolutional neural networks, recurrent neural networks, and transformer-based neural networks, right? These are the four that I'm focusing on, but there's a bunch of different other neural network architectures that can be implemented. I'm guessing once I've done these four, I'll have enough knowledge, um, and I'll have used enough of the most common neural network building blocks that all of the other architectures, I'll just be able to implement them once I understand the idea behind them. So these four are what I'm planning on um, uh, learning in terms of deep learning. So, anyways, um, I think I could start with that. ASR and NLP building blocks, and initially there's not going to be neural networks involved, but they are mentioning training. To be fair, training doesn't always mean neural networks because you have something like linear regression, for example. That model can also be trained. The weights in that case are a little different. Um, I forgot which specific. I'm gonna have to go through the entire like training process again to remember because generally there would be the weights are the line basically. Yeah, yeah. The weights are the points that form the line of best fit because you don't call it train function, you call it fit function. You fit the data to the model, and then the model predicts a line of best fit. Well, no, the model the fits the data with this line. It finds a line of best fit, and then based on that line of best fit, you can then predict something using the model. And from what I remember, the whole idea with linear regression, I don't know at what point this analogy starts to like fall apart. Maybe as you increase the dimensionality, maybe the analogy falls apart. But um, basically, it's a line of best fit, right? So you're just plotting on a line. So you just use that exact same formula to predict where exactly the thing is going to be on the line. If I remember right, yeah, that's how the prediction is also done. I'm gonna have to do this on paper to. Well, I'm gonna have to do it like manually because I'd done it in the past when we were exploring scikit-learn, but then I forgot. Hold on. Are there any? So there's the LLM. There's words. There's the LLM course on the Hugging Face website. They also had an NLP course. Okay, so let's do Hugging Face. I think it was Learn, maybe. Yeah, Learn. So there's the LLM course. There's a robotics course, which we were supposed to be doing Le Robot. And I kind of pushed that to the side because I got distracted with a bunch of other stuff. Then there's the MCP course. I definitely want to look into this now because there's a bunch of other stuff that's being built on top of MCP tech. So I kind of feel like I should be up to date with this knowledge. Um, okay, okay, okay. MCP SDKs. Sign up to the course. Don't forget to sign up to the course. How are we signing up to the course? Okay, the course is composed of foundational units where you learn the MCP context in theory, and then hands-on where you learn to use established MCP SDKs to build your applications. These hands-on sections will have pre-configured environments. and use case assignments where you'll apply the concepts you've learned to solve a real world problem that you'll choose. Collaborations. We're collaborating with Hugging Faces partners to give you the latest MCP implementations and tools. Okay, what's the prerequisites? You need a basic understanding of AI and LLM concepts. You need familiarity with software development principles and API concepts. Okay, experience with at least one programming language, Python or TypeScript. Examples will be shown. Okay, I have two of these done. And the third one, which is actually the very first point, basic understanding of AI and LLM concepts, I only kind of have that. Like I would say I have limited knowledge of AI concepts. I have explored it because obviously like I'm doing deep learning and data science and a bunch of these things. So I've explored AI concepts. I'm familiar with machine learning and deep learning concepts, but like I wouldn't say I'm necessarily an expert. To be fair, they did say basic understanding. Okay, so they said basic understanding of AI and LLM concepts. So I have a good understanding of AI concepts in general. LLM concepts, no. I need to do a lot more research on that and learn about LLMs. So if you don't have any of these, don't worry. Here are some resources that can help you, and they're pointing us toward the LLM words. They're pointing us towards the LLM course and the agents course. Dude, you know what I'm wondering? Should I do the agents course from here, or should I do the agents course from Kaggle? Because there was a Kaggle AI agents course as well, right? Uh, Hugging Face AI agents course. Okay. All right. Okay. 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 Learn the use of established AI agent libraries like Small Agents, Llama Index, and LangGraph. Speaking of Lang, there was something called Lang Chain, I think, or Chain Lang? Lang Chain. I think it was Lang Chain. Back in the day, back when ChatGPT was like fairly new, LangChain had kind of emerged and people were using it for a bunch of things. It was kind of like agents, but like not in the autonomous way necessarily. I think it was more rule based. But yeah, you could use that to like chain a bunch of different operations together. I never got a chance to explore it all the way, but that's kind of my basic understanding of it. My basic understanding of it could be completely wrong as well. So like just, don't do your own research. Don't just go based off of what I'm saying. Okay, why was I doing this? I was gonna look at holy shit. I got distracted big time. Right, MCP course, a small course, agents course, deep RL course, community computer vision course, audio course, learn to apply transformers to audio data using libraries from the Hugging Face ecosystem, open source AI cookbook, ML for games course, diffusion course, ML for 3D course. Okay, so that's all the courses that are listed here so far. And I don't think they're going into NLP. I don't think they're going too deep into NLP concepts. I could be wrong because this entire course, we have 0, which is setup, 1, which is transformer models, and then there's using transformers, so and so, so and so, so and so, so and so, so and so. Classic NLP tasks. Introduction, token classification, masked language. Dude, okay, a lot of this is heavily focusing on NLP. Sorry, a lot of this is heavily focusing on transformer based stuff. So I'm not sure how much this is really going to help me. And now I'm wondering if I should get Gemini to generate a course for me. Rust tokenizers. Rust tokenizers offers highly so and so. Okay, this is made by somebody else. It is not actively being developed. But because it mentions BERT, I believe BERT is also transformer based, isn't it? I think so. The T is transformer in BERT, isn't it? Wait, BERT. Yeah, bidirectional encoder representations from transformers. Okay, all right. Um, right. Let's just continue reading this thing that Gemini said. So, though, okay, the good thing is Gemini has given me a bunch of concepts that I can explore myself, such as hidden Markov models. The interesting thing is HMM had popped up in the early days when I was learning machine learning and I didn't really understand too much about machine learning. Hidden Markov models did pop up in that somewhere. I don't remember where exactly it was, but yeah, it did pop up there. So, okay, we have finite state transducers. That's something I need to look into, and HMM. And then there's MFCCs. What is MFCC? Hold on. Might have been mentioned somewhere here. Uh, Mel frequency cepstral coefficients pipeline. You need to implement a Mel frequency cepstral coefficients pipeline. This involves windowing, FFT, Mel filter. Dude, I'm going to have to implement this entire thing myself. Mel filter bank integration, discrete cosine transform. Someone must have implemented this. I can't be the only one who wants to do this on. I'm definitely, dude. I'm 100% not the only person who wants to do fucking ASR and NLP on embedded devices. Somebody else, multiple people, multiple other people definitely have been looking for this. So I'm sure somebody has implemented something. I'm just not looking for the right stuff. I need to know exactly what to look for. And then as I'm looking for that, I'll probably find a framework that has been built for doing all of this stuff on a higher level. Okay. On the ESP32, you compare the incoming MFCC features against these HMMs to see which one matches best. Then NLP backend, rule-based and statistics. Since you want to avoid transformers like BERT, you'll be looking at part of speech tagging and regex-based intent parsing. Tokenization and lemmatization. Rust library, stemmers. Check for no STD compatibility or a simple manual whitespace/punctuation tokenizer. The building block in a no STD environment, you typically use a Boyer-Moore search or a simple finite state machine for tokenization rather than complex byte pair encoding. Intent recognition. Okay, recommended low-level stack, ESP-HAL, micro FFT, so and so, the learning path. Okay, so a lot of the stuff you mentioned is super low level, and that's great. I'm sure I'm not the only one looking to do ASR and NLP on embedded devices. This has me wondering if the stuff you mentioned has already been implemented into some sort of framework meant for no STD compatible ASR and or NLP. In the world of no STD Rust, you won't find a single all-in-one framework like Vosk that handles everything from audio drivers to intent parsing. Instead, the ecosystem is composed of high-performance building blocks that you glue together. Since you want to avoid transformers, okay, hold on. Since you want to avoid transformers and focus on minimum latency, your embedded framework is effectively a pipeline of three specific libraries. The ASR core is Rust FST, weighted finite state transducers. Okay, why it's the answer. This is the closest thing to an ASR engine building block. It allows you to build a graph where audio features, phonemes, are mapped to words. Then embedded use, while it is powerful, you'll need to enable ALEC for the ESP32. It handles the search problem, taking a sequence of sounds and finding the most likely keyword without ever touching a neural network. Then the DSP frontend, micro FFT plus fixed. Okay, you'll need this to create the mel frequency cepstral coefficients. You'll need this to create the MFCCs. On an ESP32, you should avoid F32, which is floating point, where possible to save cycles. Use the fixed crate alongside micro FFT. Using the fixed crate alongside micro FFT allows you to do fixed point math, which is the gold standard for low latency embedded ASR. Then NLP logic is FST plus regex. Okay, you know what? We're gonna do this on PC first because I know jack shit about ASR or NLP. So I'm gonna learn it on PC first, and then I'm gonna try and implement it on embedded devices. For now, I think I'm just gonna pin this conversation so I can revisit it later on. Give me a second here. Okay, pin Rust no STD ASR slash NLP frameworks pin, and now we're going to close this and close this and close this so that we can get back to what we were doing. All right. Now here, give me a second. Super confused about Turbofish. Let's go back to Turbofish. Turbofish this, Turbofish that. Okay. Is there anything more? Okay, how the Turbofish syntax works. I'm trying to understand this. Grammar approach, Vosk, collect. Yeah, here it is. Okay. So, damn, we are like an hour and a half, an hour and almost 40 minutes into the stream. That's crazy, dude. I'm wondering if I should like rename the VOD to Turbofish plus something else. I'm gonna have to like, because there's a bunch of stuff that I looked into, right, in this stream. There's a whole bunch of like ASR and NLP related talk. There was a bunch of electronics related talk at the beginning. Yeah, I'm gonna have to. Yeah. Okay, give me a second. I need to eat like a packet of peanuts. Fortunately, I have one nearby. Give me a second. Let me eat this because my stomach keeps making sounds. I ate very light, and that was a couple hours ago. And I'm gonna eat really heavy after the stream. So in the meantime, I wanna just eat something. Give me like I don't know, 30 seconds. Okay. All right. So, um, right. So, we were here. So this is our like auto implementation of an iterator for a type for a certain struct. That's great, right? This is the collect method, which is a generic method being implemented for this struct. And in here we have from iterator from iter. Now, my question here was, how is it that we don't need to use the Turbofish syntax? We also don't need to specify any type over here. It's worth keeping in mind that there is no concrete type in this case. It's mainly the generic type. So it's the type of this generic struct. I believe it's a generic struct. Hold on, because there's a self item, right? Oh God, so many functions. Hold on. This is a generic struct. Yeah, this is a generic struct. And the type is being set to, or yeah, the type self item, which is what iterator requires, is being set to the type that's passed into the struct. That's fine. And then we have this. So this is also a generic type parameter, but the requirement here is that it should implement from iterator of this type. Right, so that's interesting. Um, the type here. So okay, let's imagine that we call collect, right? We call collect. Collect is supposed to take in a type that implements from iterator. It's supposed to take in a type that implements from iterator with this specific type that's been passed into, you know, um, whatever generic struct it is. And then it's supposed to return that same type. However, um, here it's returning from iterator. What does from iterator give you exactly? It gives you self. Yeah. Okay. Hold up. I'm trying to understand this. So from iterator. Okay, so from iter takes a type, but the type is being inferred here. The type is self. Um, self would be my struct u, right? Where is a being used? A is here. Um, where t, okay, a equals u. U is the type that we um is the type that we passed in as the concrete type for the generic parameter. So my struct O1 has been initialized with that type, and then A is being, okay, T is not being returned, right? Self is being returned. I need to keep that in mind as well. Self is being returned. What would self be in this case? Okay, self equals B. I'm glad that they have these things mentioned down here because this, dude, this really helps. This, everything that's within this, it is super, super helpful. Okay. Self equals B. Our B is not mentioned over here, but it's mentioned in collect's definition. Oh, that's what self is. Okay, okay. Self equals B, and then A which is being passed into, or rather, it's being compared against, I should say. A is, hold up. So self is B. Wait, I have a question here. Okay, let's do that and close that. Okay, I'm doing Rust coding in NeoVim, LazyVim. There's a hover function that is key mapped to the K key, which is Shift plus K. So I can move my cursor over a function call. Hit Shift or hit K, and then a little floating window pops up with the info. If I hit Shift, if I hit K again, then the cursor moves into that little floating window so I can scroll through the text in it. That's great. What I'm wondering is, oh wait, let me also mention, to close that window, I just need to hit Q. To close that window when my cursor is in it, I just need to hit Q. That's great. What I'm wondering is there a way to move this floating window around? Okay, to jump into the float workflow is a classic NeoVim power move, but moving the window isn't actually a built-in feature of the standard LSP hover. By default, those windows are anchored to the cursor position where you triggered them. However, since you're using LazyVim, you have some cool options to get that window out of your way or reposition it. The no-code workaround, scrolling without jumping. If your goal is to see more text without the window blocking your code, LazyVim usually lets you scroll the floating window without using the cursor, without moving your cursor into it. Try the, that's not what I was looking for. Moving the window, that's what I was talking about. NeoVim doesn't let you quote unquote drag a float with the mouse easily, but once you hit K a second time, your cursor is inside the window. It's technically just another window buffer. To move it, you you can use the standard NeoVim window movement commands. While inside the float, try. Wait, this moves a I've never moved a floating window. Okay, this will try to move the window to the far side of the screen, effectively detaching it from the cursor and making it split. Oh, um, okay, let's try this. Okay, that does not work. Okay, what about Control W? Oh, this is what it's saying. Move window to the far left. Okay. Okay, then this, move it to the far right, and now it looks like this, but seems like a mess. I don't think I want to do that. Let's just stick with this. Whatever. It's not that bad. Okay, back to what I was doing here. Wait, okay. If I could move this. So the problem now is that the floating window is still there, so it's not like, yeah, the floating window is still there, so it's still like a problem. This did create two separate windows, and that's great. Uh, yeah, the moment I move the cursor out of it, it closes. That's okay. That's okay. All right. So where was I? Self. Self equals B. B in this case is what is B in this case? B is the parameter that gets passed in, which is why we have to be specific about it. So B is a generic function. B is not a generic function. Collect is a generic function that takes a generic parameter, a generic type parameter B, which is different from the type of this struct, or it's different from the type of this iterator and the type of this struct. So we need to specify a type for this, right? And then it returns the same thing. But then what exactly is it doing if it's returning the same thing? Because like it's one iterator and it's converting it to a different type of iterator. That's all that's happening, right? That's kind of what makes that's kind of what makes sense to me here. Like, okay, um, I need only this. So I'm just gonna copy this. Let's yank this and then undo and then give me give me a second. I don't know what's in the copy buffer. Okay, we're good. All right. So we have our collect thing here. Okay. I needed to delete all of the other stuff because it's a bunch of them were throwing errors. I had to make some changes there. Right. So here we have a range. which we can convert into a vec32. We can convert it into a vec32. Now, there has to be like a bunch of other things that implement what what does uh, what does an array look like? I already have H there, so let's do H. What does this show up as? Shows up as an array. Okay, all right. Would I be able to call collect on this? Dot collect. That's interesting. I think that might be a. I need to look into that. How is iter mentioned here? But also, it's probably going to throw an error, right? Because I haven't given it something. Okay. The type in this case. Back up. This is not an iterator. If I had to convert this to iter, this is not an iterator then. Though after we convert this to an iterator, we can just call next on it, right? So at that point, it's an iterator. We can easily convert it to any other type of iterator. I mean, well, okay, so this is not an iterator. That's my point. I was trying to, you know what? Wait, hold on. Give me a list of Rust types that implement iterator. Because I can think of hash map and hash set, but I haven't used hash set nearly as much to be comfortable with using it in this example. And hash map is more like key based. So like I would have to provide a key and then a value and then a key and then a value. So like a dictionary kind of thing. Okay, adapter types. There's map, filter, enumerate, zip, take, skip. These are all types. Rev reverses the direction. Okay. Collection iterators. I probably should have mentioned that. Iter. Iter returns, iter implements the iterator trait. There's vec, there's hash map, there's b-tree map. I haven't used b-tree map. Um, I should look into b-tree in words. I should look into b-tree map though. Okay, then there's range type. Range written as so-and-so. Okay. Ranges are some of the most frequently used iterators for numerical loops. All right. Okay. Range does include, oh, I could do that. Wait. Back up. I could, I could, I could try to, so let me specify a type here. Let's say range I32. Is that going to work? Doesn't work. Cannot find range in this scope. Um, let's do this. It cannot find range in this scope. Oh, do I need to like add something? Oh, it might be that. Actually, I don't know which one of these it is. I think it's this. Use of unstable library feature, new range API. A value of STU range cannot be built from an iterator over elements of type integer. Which range am I supposed to be going for then? Okay, let's undo that then, I guess. Um, the method call chain might not have had the expected associated types. Which specific thing am I looking for here? Let's try ops. I don't know. Does that work? But then that's a different thing, isn't it? Man, let me just look this up. But it says range IDX. Chars split lines yields lines from a buffered reader. There's repeat. Okay, okay. All right. Let's open up a new conversation. Hey, when I do this in Rust, which specific range type is that? Because when I'm trying to use type annotation, I keep getting errors because there are multiple range types and I don't know which one I'm supposed to be using. Okay, Rust's range types are like a choose your own adventure book. Okay, okay, all right. When you write this, it's the ops range thing. Okay, all right. I think the error here is coming probably from this. Right. The method collect exit. Wait, back up. I made a mistake. No, iter is still necessary because array needs the thing. The method call chain might not have had might not have had might not have had the expected associated types. A value of so and so cannot be built from an integer over elements of type so and so. The trait from iterator is not implemented for so and so. Okay, let's try something here. Okay, I don't know if this is gonna work. That doesn't work. Okay, you know what? I'm trying to recreate an example here, and that's not working out. But whatever, we can move on from this because I'm trying to understand something else over here. Now, let's get back to this thing. So we were looking at from iter. Okay, from iter takes a type t. It returns self. Self is supposed to be b. Self is supposed to be b, and b is what you are passing in. B is what you are passing in. Dude, you know what? I'm curious about this. Um, if let's go back to that line. I'm curious here if I would be able to convert a vec into Okay, that wasn't the issue then. Yeah, that wasn't the issue. Okay, let's try hash map. Hash map requires two things, I believe, right? Oh, wait, no, it's saying three things here. S is a random state. I don't think I need to specify that. Let's give I32 and I32, and hopefully I don't need to specify S. Let's try doing this. Okay. Uh, that's not required. We can get rid of that. So-and-so cannot be built from an integer over elements of type so-and-so. I need to look into what exactly this, hold on. Wrong. This, yeah, I need to look into what this means over elements of type so-and-so. What if I made it, this is a range. Okay, what if I did vec and we do two ranges, or we do, well, this. That still doesn't work. Okay, I need to look into this later on. For now let's concentrate on doing this thing. We're trying to trace this back. Okay, so in this case, our B type is vec I32. Hey, give me just a second here. Just checking something. Okay, all right. Just a second. I'm just checking something. Yeah. Okay. So self is self is in this case it's going to be vec I32, right? In case if we do pass in, can I actually do that with like using my own type that I provided? So let's make it I32. Um, type equals u. Okay, let h equals my struct. Uh, can I do it in this way? Does that work? Missing fields. Okay. Right, then, I mean, the type annotation is kind of a waste. Okay, h dot collect. Let k equals h dot collect, and here we can specify vec I32. Is this gonna work? Oh, it's a different way of doing it. Okay, yeah. Comparison operators cannot be chained. Is that right? That's right. Okay. So this is where we are using, this is where we are able to use the Turbofish operator, or the Turbofish syntax. Sorry, we're able to use the Turbofish syntax to specify a different type and convert this type into, or this iterator into a different type of iterator. Right. We can get rid of all of this. We don't need to. Okay. Now, self is going to be B. What we are passing into B here is vec I32. B implements, okay, where does so T from iterator T is my struct. This takes in my struct. Oh, that makes sense. So from iter takes self. So it consumes this instance. It's consuming it, isn't it? So if I do L equals h dot collect, and then we do the same vec, oh wait, vec I32. Yeah. So this has been, at this point it has been moved. Okay, now from iter consumes an instance of this type. So from iter is consuming this instance using using self, and this is a generic function. This is a generic function. This is supposed to return self, but what would self be in this case? Self equals B. Self equals B. So then B would be vec I32. There's a whole lot of like jumping around going on here. We're like, I'm trying to understand this. So if self is, and that's what's happening, right? Because the function is eventually returning B, and that is here. From iter is also returning type B. From iter is also returning type B. So it makes sense that self is wait, what happens if I implement from iter on something? Let me see what the implementation is there. So let's say struct my struct o2. Let's make this generic as well. A, T, sure, whatever. Then impl my what was I doing? Impl from iterator. From iterator for, I guess we need types here. Okay, so let's do U for my struct O2, type U, and then I'm guessing this needs, okay, so this needs a from iter for sure. If I hit save here, we're gonna have this issue. Unwrap. Oh, wait, back up. Let's go to the specific thing. Okay, we don't have the specific thing. Missing generics for trait from iterator. Oh, it's missing the A argument. How am I specifying A? Okay, what happens now? That's okay, let's try this. No, that's not gonna work. See, I was assuming that it would be as simple as like this, type and then item equals, it mentions A here. Item is supposed to be, oh, is this a good idea? No, this is, no, that's not going to work. I need to understand what is going on here before I actually just start plugging arguments into stuff. Wait, back up. Let's delete this. Okay, so it's going to say that not all the stuff is implemented. Let's implement the missing members. Okay. Now, this is supposed to take in. So from iter is supposed to take in an iterator. The iterator in this case is supposed to be this instance, isn't it? Yeah, the iterator in this case is supposed to be this instance. Do we need like multiple things here? But then there's also no T. No, there is T already. Would this fix the issue? Okay, that fixed the issue. From iterator apparently needs a type. From iterator needs a type. So now if we do this and where's main? Here. Okay, so we have, yeah, let's remove this type annotation and make this struct O2. Okay, h dot H doesn't have from iter. How are we meant to be using Rust method collect not found for this struct? Where is collect? Wait, back up. Get rid of that. Save. Field in this struct. That's all it says. Field in this struct. All right. I forgot why I was doing this. I think I was trying to understand this. So from iter, oh, also up there it does mention from iter takes a as a argument. Oh, you know what? What if I used a type here? How do I do this? Okay. H this is gonna be so weird. I don't know if this is gonna work. This is not gonna work. Is this gonna work? I don't know if this is gonna work. Um no, that doesn't either. Okay, hold on. Let's go back to this. Right. So, from iter consumes an instance. Right? In this case, when we call, let's go up here. Let's delete this, just so I can see the code. This is my struct O2. Change this to 1, and we should be fine now. Okay. Collect. Collect is an instance method, right? So we are able to call collect on that. But then in collect, we are supposed to pass in collect, we are supposed to pass in the type annotation. So here we are passing in self. Self is the instance itself. All right. Okay. And then this is our B. Our B in this case is vec I32. Vec I32 self item. Item is being described here or defined here, and U is being pulled out from. So the type has to be the same. Well, the generic type inside that iterator has to be the same. You can't change that, but the iterator type can change. Okay, all right. So that's why we need to make sure that we need to make sure that um, the the iterator type that we are trying to um, return or convert this to, we need to make sure that that iterator type is it implements from iterator, and specifically it implements from iterator of type um, specific. I'm not sure how to say that, but specifically it needs to implement from iterator and have the same type that this struct was initialized with. And because that is the case, we are able to pass in a vec and get, or we're able to pass in a range and get a vec. However, others don't seem to work that well. Like, okay, I used a range. I used a, okay, here we have a struct. The struct implements collect, and so I'm able to return this as, or the struct implements iterator, or is it from iterator? No, it implements iterator, and because of that, I'm able to use collect to get an iterator out of this. Hold on, this also implements next, so this is an iterator. I didn't take that into account. This is an iterator itself. We are just converting this to a different type of iterator. Now, okay, what if uh there's supposed to be GHIJK. Okay, so let's do I here. Let's change this to I. Um, and then here J equals, wait, what was I gonna do? Yeah, I was gonna convert this range. I just remembered I have something up here already, so I don't need to do that. Has F been consumed? No, it hasn't. So, what we are gonna do is for I, wait, let's, yeah, for I, or let's say num in uh, F. But I guess it's better to just consume the iterator completely. We can print out. Okay, so it has to have a way to implement this, doesn't it? So in the case of range, it's able to expand that range into how many ever numbers that is. So I can do this. Um, Wait, it says not yet implemented. On which line? 67. Oh, wait, back up. Uh, that's to do. Okay, that's fine, but am I calling? Oh, it panicked. Okay, that's why it stopped. It panicked. So it's not giving an error, but like in trying to generate a collection out of this, and in trying to convert this to vec, it called next, and then that's why it panicked. So this is our range, 0 to 10. This is our range, 0 to 10. I want to try and convert this to something else. Let's say a hash map and then I32. Let's see what is going on. Okay. Oh, all right. There is an error here. A value of so and so cannot be built from an integer over elements of type so and so. Okay, from iterator integer is not backup. Did it not mention something about yeah, is sized implemented for the other types, for something like hash map, for example? Because that could be part of the problem. Okay, let's get back to vec. I think it's this. Okay. I I I kind of forgot what I was doing. Let's get back to collect from iter. Right. So, from iter consumes the instance t. T has a trait bound of into iterator, and the type has to be a. And in this case, the type a, if we look down here, I'm assuming wait, back up. If I look at this, would I get a? No, in this case, I wouldn't get a. If I look at this, I'm not going to get it. Oh, a equals u. Okay, it's down there. So a equals u. U is already there. So this says that we can only convert this iterator into an iterator of that type. So if the range is an I32 range, the iterator, for example, vec, has to be vec I32. That's what this is saying. Right, and that is being satisfied. So that's fine, and that returns self. That can be any collection. That can be any, sorry, iterator. T is our type here, and T is mystruct01 in this case. Um, mystruct01 has a generic type parameter, as generic type U, and so A should be the same type as U. That is being enforced. Self equals B. Self equals B, and B's, where's the enforcement for B? Oh, the enforcement for B is here. The type has to be self item. Well, the type has to be item. So the type has to be the same type as, um, the type has to be the same type as U, basically. Okay. All right. Now, going back to what I'd asked Gemini about why I don't need to specify a type here, why I don't need to use something like Turbofish in this case, and how it's just inferring the type. Let me confirm which type exactly it's trying to. Oh, wait, if I reread this, maybe it'll automatically become clear what the type is, because the definition is right here. The definition is right here, right? So maybe we can just pick it up from here. From iterator A. Okay, that is something I need to look into. What just happened? Okay. All right. From iterator, when we call from iterator, it's going to follow these rules. A is equal to U. How is that happening though? The definition doesn't specify anywhere. Yeah, the definition is not specifying anywhere what A is supposed to be equal to. In this case, though, um, A is being set to the same type uh, as whatever type is passed into mystruct01. So in this case, it would be from, wait, so then it would be from iterator I32. Can I just do that? Can I, is that, is, hold on. Yeah, is that a possibility here? From iterator I32, that doesn't work. That does not work. Yep, that doesn't work. Okay, what if we used a different way? We are supposed to pass an iterator into this, right? Let's create an, oh yeah, actually we can just do this. So we are passing in a range. We will create Hij. Okay, so here we need type inference, but the main issue here is that it's saying cannot call associated function on trait without specifying the corresponding impl type. Okay, what if I did this vec I32 mismatch type? It expected a vec I32. That's not, no, that's not what I was going for. Yeah, that's not what I was going for. Okay, let's go back to let's go back to this. So what I'm wondering here is how A is being passed into this. Okay, we know that A is supposed to be A is equal to U, but that rule is not being specified anywhere. Actually, that's probably why I implemented this, right? Equals A. But even here, I'm not specifying that A is supposed to be equal to, yeah, yeah. Even here, I'm not specifying that A is equal to U. Where is it getting this from? So what more am I confused about here? Self is equal to B, that's perfectly fine. That's going to be a vec I32. A is equal to U. But how is A equal to, well, okay, then I could also ask the question, how is self equal to B? But then like I'm satisfied with saying that, oh yeah, the compiler is telling me that self is equal to B. So it's inferring the type. But then yeah, where is that coming from as well? Okay, so keeping these questions in mind, right? I'd asked. So this brings us back to the conversation I was having with Gemini about this type inference thing. I said this. I'm learning Rust. In the past, when I've tried using from iterator from iter, I got an error, and it turns out I was supposed to use Turbofish syntax to specify the type. Oh, backup. No, 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 backup. Wait, wait, wait. I just remembered something here. I'm not supposed to specify self here. Oh, I am supposed to specify self. Self is the range. Self is the range. Yeah, yeah, no, I haven't figured out why this is causing an issue. Could it be where I've placed this? Okay, let's read what Gemini said. Well, I let me read out my prompt to it first. Let me read out the prompt that I gave to Gemini first. Okay, I'm learning Rust. In the past, when I've tried using from iterator from iter, I've got an error, and it turns out I was supposed to use Turbofish syntax to specify a type and then call from iter. You also mentioned that in 99% of my Rust code, I will rarely ever be using that. I tried to implement the default iterator members on a struct and noticed within the generated collect function code that from iter was being called. What I'm confused about is Where is it getting its type from in this case? So now my question is a little different. Now my question isn't exactly that, but I'm going to read the answer anyways. It's a great observation. You've stumbled upon one of the most elegant pieces of magic in the Rust standard library. The reason collect seems to know the type without a turbofish most of the time is that it doesn't actually know it internally. Instead, it acts as a bridge between your iterator and the type inference engine. How collect is defined. If you look at the source code for the iterator trait, collect looks roughly like this. Okay, yeah, that's what my collect looks like as well. Notice that B is a generic type parameter. When you call collect, you aren't just calling a function, you are calling a function that must return some type B that implements from iterator. Okay, where does the type come from? The compiler uses backwards type inference. It looks at how the result of collect is used later in your code to determine what B should be. Okay, there are three main ways Rust finds the type. Explicit variable annotation. Okay, all right. Function signatures. All right. So it's looking at the type that's being returned by the function. And in explicit variable annotation, we are looking at explicit type annotation. Okay. And then the turbofish syntax, which is the emergency break. Okay. The internal call. Inside the implementation of collect, the line from iterator from iter works because it uses that. Oh, oh, back up, back up. Function signature. Function signature. Okay, it uses the function signature. The function signature in this case is returning B. Okay, it just clicked. Previously when I read it, it didn't click. Okay, all right. So it's using one of its rules, right? One of its ways to determine. Sorry, zoned out. Okay. So in this case, when it needs a generic parameter, it's using the function's return type, and the return type in this case is supposed to be B. Is that also how from iterator is getting A? Because A is equal to B. Sorry, A is equal to U, not B. Hold on. A is equal to U, not B. Okay, I still don't get how it is, because there's an added level there. There's an extra level there, right? B is encapsulating U. Yeah, B is encapsulating U in this case. How is A equal to B? What rule is being used there? Let me. Okay. All right. The internal call inside the implementation of collect, the line so and so works because it uses that generic B. Because collect returns B and from iter returns the type it's called on, the compiler links them together. From iter returns the type that it's called on. Is that true? Yeah, from iterator return. No, from iterator returns the type that it's, oh, the type that it is called on. So in this case, it's returning my struct o1. Okay, okay. All right. I'm slowly connecting the dots here. Because collect returns b and from iter returns the type it's called on. Um, Again, in this case, the type. Wait, b is supposed to be vec I32, isn't it? Wait, I'm losing the connection again. Uh, okay. From iter works because it uses that generic b. The generic b in this case is our um, is this, right? And the type of b is being inferred from, oh, the type of b is inferred from the turbofish syntax or the type annotation. Yeah, yeah, could be the type annotation as well. Okay, it's like a relay race. You tell the variable what you want, which is a vec. The variable tells collect it needs a vec. Collect tells from iter to produce a vec. Why you hit sorry, why you hit errors from why you hit errors with from iter directly? When you call from iter so and so directly, you are bypassing the collect bridge. Unless you have a very clear type hint on the variable receiving the result, the compiler gets lost because from iter is an associated function of a trait, not a method on the iterator itself. Okay. It's often easier for the compiler to work with iter.collect because it can see, quote unquote, the data flowing from left to right and bottom to top simultaneously. Speaking of from iterator, um, I tried implementing from um, iterator on struct, my struct o2, I think. Yeah. No, I shouldn't do it in that way. Speaking of from iterator, I tried implementing iterator um, on on a struct, my struct o1 t, and I implemented two methods, next and collect, or rather, I auto generated two methods, next and collect. In collect, I saw the default uh, collect code, which is basically that from iter call. I I called or I triggered hover over that from iter call to see what some of the generic types might be. Now let me see if I can copy this entire. Okay, so we have this here. I can probably do a block thing and just copy this entire thing. What the generic types might be. This is what Hover showed me. Oh man, okay. That the formatting is perfectly fine. I was worried that it would get butchered. Okay, what's confusing me is how is the compiler assigning U to A and B to self? Okay, this is a classic case of generic soup. No shit. No shit. This is a hell of a soup. Okay, when you look at the hover card in your IDE, the compiler is essentially showing you a substitution map. It is trying to align the specific implementation you are looking at with the abstract definition of the trait. Here is the breakdown of how the compiler solved, quote unquote, solved for you and for U, B, and my struct. All right. The two definitions. To see the mapping, you have to look at the source where the call happens and the distinction and the destination, the trait being called. Okay. The source, iterator.collect. Inside the standard library, collect is defined like this. Okay. From iterator, so and so. Yep. Standard collect signature. B is the type of the collection you want to create. Example, vec, hash set, so on. Self. Self is big self in this case. Actually, there's two selves. There's big self and small self. Self, the iterator itself, in your case, my struct O1, okay. Self item, the type of items the iterator spits out. That's a good way to put it. The type of items that the iterator spits out. In your case, it's you. Okay, so I32. The destination from iter. Oh, from iterator, from iter. The trait you are calling looks like this. Okay, all right. The mapping logic. The mapping logic. When the code inside collect calls from iter, the compiler plays a game of match the variable. Self, the collect method returns B, so from iter must return B. So self equals B. T, you passed self, the smaller self, into the function. Self is your struct, so T equals my struct. And then A, the trait requires T. The trait requires T to have an item equal to A. Since my struct U has item equals U, then A must be, oh, that's how it's enforcing the rule. That because my struct's item is U, so from iterator's item is also U. All right, why does it look so cryptic? The reason it showed you U instead of T from your mystruct T is usually because of how the LSP or compiler internally renames generic parameters to avoid shadowing. B is the bucket. U is the unit. Oh, I didn't realize that they had like some specific meanings. Okay. B is the bucket, the destination collection. I should keep that in mind. U is the unit, the individual items inside the bucket. I need to keep this in mind because I'll be able to remember it this way. Okay, the aha moment. The reason you don't have to specify these manually when you're calling .collect is that B is determined by the return type of the variable you're assigning to, and U is determined by the iterator you're calling it on. The hover card is just showing you the plumbing that connects your struct to the logic from iterator trait. Okay, all right. Holy shit, dude. We have now been streaming for 3 hours, and that is insane. That is insane. I don't usually do 3 hour streams, but that is crazy. Hell yeah, dude. Um, give me a second here. Um, who should we go to? Um, okay. So I don't know who this person is, and what they're studying. It looks like they're studying math or science, one of these two. I think so. I'm not sure. They're actually let me see if I'm able to even start the raid. I don't know if they have any settings that prevent raids. Okay, no, we are good. Okay, so yeah, we're gonna be raiding someone named the Great Senku, and they are doing a study stream. But yeah, that's gonna be it for today's stream. Dude, we made some progress today. We made some good research progress. I still have a lot more progress to make in this area, especially with turbo syntax, turbofish syntax. Um, and I need to connect the dots with, like, from iterator, from iter, and turbofish, and eventually we'll get back to iterator itself and use like collect and map and stuff like that. But yeah, okay. That's going to be it for today's stream. We have done a 3 hour stream today, which is very rare for me. And that's awesome. Hell yeah. We are almost at the end of this month, and I've been streaming almost daily for the entire month because I restarted the streams on like the 3rd of Jan, and prior to that, So I didn't stream on the 1st and 2nd of Jan, but like previously I was already streaming. Okay, okay. Anyways, that's gonna be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.